There are three ways that objects can acquire a net charge. What we see here is an example of charging by friction. Electrons are being transferred by friction when one material rubs against another. Because electrons are lost by one material and gained by the other, the objects now have opposite charges and attract. This is the same situation that occurs when you rub your feet across carpet and are shocked by contact with a doorknob.
Ouch.
The shock you feel is electrons moving from your body to the doorknob. This is known as a discharge. After the discharge, your body is neutral again. Electrons can also be transferred from one material to another simply by touching. When a charged rod is placed in contact with a neutral object, some charge will transfer to the neutral object. This method of charging is called charging by contact. If the object is a good conductor, the charges will spread to all parts of its surface because the like charges repel each other. Charging by induction can be shown using two insulated metal spheres. Uncharged insulated metal spheres touching each other form a single non-charged conductor. When a negatively charged rod is held near one sphere, electrons in the metal are repelled by the rod. Excess negative charges move to the other sphere, leaving the first sphere with an excess positive charge. The charge on the spheres has been redistributed or induced. When the spheres are separated and the rod removed, the spheres are charged equally and oppositely. They have been charged by induction, which is the charging of an object without direct contact. Charge induction by grounding can be illustrated using a metal sphere hanging from a non-conducting string. A charge redistribution is induced by the presence of the charged rod. The net charge on the sphere is still zero. Touching the sphere removes electrons by contact, and the sphere is left positively charged. The positively charged sphere is attracted to a negative rod. When electrons move onto the sphere from the rod, it becomes negatively charged by contact. When we touch the metal surface with a finger, charges that repel each other have a conducting path to a practically infinite reservoir for electric charge, the ground. When we allow charges to move off or onto a conductor by touching it, we are grounding it. Charging by induction also occurs during thunderstorms. The negatively charged bottoms of clouds induce a positive charge on the surface of the earth below. Most lightning is an electrical discharge between oppositely charged parts of clouds. The kind of lightning we're most familiar with is the electrical discharge between clouds and oppositely charged ground below. If a rod is placed above a building and connected to the ground, the point of the rod collects electrons from the air. This prevents a buildup of positive charge by induction. The primary purpose of the lightning rod is to prevent a lightning discharge from occurring. If lightning does strike, it may be attracted to the rod and short-circuited to the ground, sparing the building. Charging by induction is not restricted to conductors. Charge polarization can occur in insulators that are near a charged object. When a charged rod is brought near an insulator, there are no free electrons to migrate throughout the insulating material. Instead, there is a rearrangement of the positions of charges within the atoms and molecules themselves. One side of the atom or molecule is induced to be slightly more positive or negative than the opposite side. The atom or molecule is said to be electrically polarized. When an external negative charge is brought closer from the left, the charges within a neutral atom or molecule rearrange. All the atoms or molecules near the surface of the insulator become electrically polarized. Rub an inflated balloon on a sweater and it becomes charged. Place the balloon against the wall and it sticks. The charge on the balloon induces an opposite surface charge on the wall. The charge on the balloon is slightly closer to the opposite induced charge than to the charge of the same sign. Many molecules, H2O for example, are electrically polarized in their normal states. The distribution of charges is not perfectly even. There's a little more negative charge on one side of the molecule than on the other. Such molecules are said to be electric dipoles. Thanks for stopping by. We'll see you next time.